please. Let me do this.
Baby, ufuna ati bwanjagi you want tissue?
Okay, so we're now looking at the conditional probability quantitative method, getting down to probability, and also looking at the probability types that we need to actually look at. So in particular, we are looking at conditional probability. So this is the probability that is computed based on other probabilities given. That is under the conditional probability. Okay, so we're getting to this question 5. under conditional probability, we'll just look at the composition of this exercise that we need to do. So for this one, we really need to understand the fact that this conditional probability is on an aspect where we look at the probability computed based on other probabilities given. So, e.g. probability of A given B, so is equal to probability of A intersection B or probability of B. So what we are given comes down. Okay. So this one is on one of the conditional probabilities. The second one is where we look at probability of B given A is equal to probability of B intersection A or probability of A. Is also a conditional probability. In probability of C given A, an example, is equal to probability of C intersection A over probability of A. So what is given? This is C given A. Okay, so this is it about the
Sorry, we can't hear you. The next connectivity that I can't hear anything.
all right, so this is it, the probability of C given A. Then we're gonna also probability of A given B is equal to probability of A intersection B or probability of B. This is only the probability of A given B. Is equal to probability of A intersection B over probability of B. So what we are given comes down. Then we can have also the other type of probability where we say probability of A complement intersection B. So is equal to probability of B then minus probability of A intersection B. So probability of B complement intersection C You look at probability of C minus probability of B intersection C. Probability of D complement intersection A. Look at probability of A, then minus probability of D intersection A. So this is about what these values go from. All right, so now this is on aspect of Conditional probability. So an example, we may be given, you know, are people with me so far?
Yes.
Yes,
Okay. Okay, thanks very much. So I will take this class based on, okay? So like an example, if you are given a probability of A, example probability of A is 0.4, and then probability of B is 0.2. Then probability of A intersection B is 0.3. Okay, now find probability of A given B. Number one. Then find the probability of B. Find probability of B given A. Okay. And of course, we can go an extra mile. Find probability of A union B. So, what is the first answer on the first one? Probability of A given B. Who can tell me what you're going to do about? What's the formula for the first one?
it's going to be equal to probability of A intersection B over probability of B.
The first one says what?
Probability of A intersection B
So probability
over
of
probability of B.
A intersection B over probability of B, correct. So what are we getting now? 0.3. The probability of B is 0.2. So for this one, we can find the answer. What answer are we getting? You can give me an answer for that one?
1.5.
1 point?
1.5.
Okay, let me just revise it because any probability should not exceed 1. So let me put this one as 0. Let me just resolve this one 0.1. Pardon me for I just came up with this one abruptly. So to be 0.1 over probability of B is 0.2. Let's now resolve this issue. What else are we getting?
0.5.
Oh, okay. So that is the answer for this one. You don't have to find any probability that is above 1, please. So I just came up with this example abruptly. So what about the other one? Probability of B given A. You look at what? Probability of B intersection A or probability of A. So this is easy. Or now you go for for this one. So the probability of B intersection A, the same as probability of A intersection B. So it will be what? 0.1, or probability of A is 0.4. So probability of B given M is equal to probability of B intersection M or probability of A. So probability of B intersection A is 0.1 from here, or probability of B, or probability of A. So B given A, or probability of A. So probability of A is actually 0.4. So we can sort out that one. 0.1 divided by 0.4, 0.25. So 0.25. So that's the probability of B given A. Okay, now we need to find probability of A union B. So it's equal to probability of A plus probability of B, then minus probability of A intersection B. That's the formula for the union set. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay, so this is about what this one goes on. So probability of A is 0.4. B is 0.2 minus the intersection set of 0.1. So probability of A union B, you are correcting what is in A and B minus the intersection set. So what we are simply saying is here A is 0.4 plus what is in B is 0.2 minus the intersection set which is there of 0.1. We're simply saying we have the 0.5 here as the probability of A union B. Now this can be presented in a Venn diagram because the intersection set is 0.1, an example. So when you come to the Venn diagram, under this one, A and B, A and B, so here it's 0.1. Then probability of A is what? Probability of A is 0.4.
0.4.
0.4. Okay, so I'll give you an example to try just about after this one. So the probability of A is 0.4. So meaning that what is remaining inside is 0.3. So that when you add this plus this, you get 0.4. For B 0.2. So it means what we are going to have here is what? 0.1. So B is 0.2. So meaning that probability of A union B is equal to 0.3 plus the 0.1 plus the 0.1. So the answer will give us a 0.5. This is the probability of that. Now, are events A and B independent if you're testing for independent events? Because these conditional probability go together. So you carry out the test for independent events. One test, so testing for independent. We have the first one, probability of A intersection B is equal to probability of A multiplied by probability of B if events are independent. Okay, so that's the first test. So here we have already have 0.1. Is it reconciling with probability of A? The probability of A is 0.4, B is 0.2. So we have to multiply these. If they are going to reconcile, then meaning that the events are independent. So 0.4 by 0.2. So 0.4 by 0.2. If these will give us the same answers, then events are independent. But here we have the 0.4 multiplied by 0.2, which is 0.08. 0.08. So events are not independent. Not independent. So events are not independent. Similarly, probability of A given B should give us a probability of A if it are independent events. Are we together there? Are people with me?
I just want
Yes.
to ask, is there an explanation behind the equations for the test? Like, for instance, how you explained to us the equations for the intersection for the union, A union B is equals to this minus A intersection B. There's an explanation to it. There's an explanation for the equation for testing for independence.
Okay. So, I didn't get the question clearly, but the union is a collection of sets. What is in A and B? But you should avoid the repetition. So an example, if you have probability of A, if it is equal to 0.2, probability of B, an example, if it is 0.4, and probability of A intersection B, if it is 0.1, it means that the union set is a collection of what is in A and B, but avoid repetition. So you are going for what is in A. Is that what you asked about, boss?
Yes, so the way you've explained that one, I said that that one was very well understood. That's why we were subtracting the intersection of 0.1. So now for the
Correct.
test for stability, they are giving us formulas to say probability of A given B is equals to probability of A, or the previous one that I got from doing it said probability of A intersection B is equals to probability of A times B. So is there some right explanation, or are they just standard formulas?
Okay, so this is a standard way to go about this one. The formula is probability. So probability of A union B, you simply say is equal to probability of A plus probability of B minus probability of A intersection B. All together.
Yes.
So that's a formula to use. So meaning if you're using a Venn diagram, you can still get the same ones.
Sorry to disturb. We can't see the formula. Are you able to do it on a bigger
Okay.
space?
Okay, so we are simply saying probability of A union B. Okay, you're able to see now? All together.
Yeah.
So this is it, the formula to go for probability of A union B. So you got the probability of A plus probability of B minus probability of A. You remove the intersection Z because it's complicating, duplicating what you have. Okay. So it's probability of A. If it is 0.2, probability of B is equal to 0.4. And then probability of A intersection B, if it is 0.3. Okay, like, or maybe just make 0.1. Okay. This one, I can even say probability of A is 0.6, doesn't matter. Probability of A is 0.6. What is important is the concept probability of A, 0.6. We have probability of A, which is equal to 0.6. Then probability of B is 0.4. The intersection set is 0.1. Then who can give me the answer for probability of A union B? What answer are we getting for probability of A union B? Who can you give me the answer if you have this information? Are we together? Hello?
Yes, we are. I think
So what's the answer for probability of A union B?
so. You have
0.5.
probability of A
Hmm?
plus probability of B minus probability of A intersection
Oh,
intersection A and B, then gives you 0.9.
correct. Correct. So that's the first one. Now, what's the probability of A given B? Who can answer for me probability of A given B? Probability of A given B? So A given
So
B,
it will be probability of A intersection B divided by probability of B.
Okay, so A intersection B or probability of B, correct. So A intersection B is what? The question? 0 point what? 0.1
0.
also. Or probability of B is what? 0 0.2,
0.4.
0.4. Of B is 0.4. So this one will give us what answer?
0.25.
Correct. So this one will give us a 0.25. 0.25. Then what's the probability of B given A? Who can try?
So to be probability of B intersection A divided by probability of A.
Okay, correct. So the probability of B intersection M or probability of A. So this is conditional probability that you are doing here. Okay. So probability of A intersection B is the same as probability of B intersection A. On the first numerator here, it's one and the same thing. So we are going to have 0.1 over probability of B. Zero 0.4, not so. All together. So 0.4. You get the answer. Who can give me the answer for probability of A complement intersection B? What did I say about this one?
Hello? You said
I think it should be 1 minus the probability of A intersection B.
Yeah, let's continue. Okay. So this is about what is going on here in terms of the probabilities. So now, if we're to find probability of A intersection B, is equal to probability of B, then minus probability of A intersection B. This is about what we have on this one. So getting down to this one here, we have 0.1 divided by 0.4, 0.25 on the probability of B given A. And then probability of B is from the question, probability of B is 0.4. So you put the 0.4 minus the intersection of the two probabilities, which is 0.1. So the answer will give us a 0.3. Then, if I had to find the probability of B intersection, B complement intersection A, so it's equal to probability of A minus probability of B intersection A. So probability of A, we have to check for it. Probability of A is 0.6. Okay, so 0.6 minus the intersection set of 0.1. So the answer is 0.5. So this is only probability of B complement intersection A. Okay, so this is about what, and then when we're carrying out the test for independent events, if events are independent, it means that the probability of A intersection B is equal to probability of A multiplied by probability of B if events are independent. So we have to carry out the intersection set already, which is 0.1. We have to say 0.1 is it equal to the probability of A product by B, product of A, which is 0.6 multiplied by 0.4. Okay, 0.6 multiplied by 0.4. Is that reconciling with this one? So the 0.6 times 0.4 is 0.24. So events are not independent in this way. And these events, they may not be mutually exclusive, because mutually exclusive are disjoint events. So when we talk about mutually exclusive, so these are disjoint events. So they have no intersection set. The mutually exclusive, they are disjoint events. So meaning that probability of A intersection B is equal to 0 for mutually exclusive. Then probability of A union B is equal to probability of A plus probability of B. So these are the mutually exclusive events. All right. So by virtue of having an intersection set in this kind of a problem, it means events are not mutually exclusive because they have an intersection set of 0.1. Mutually exclusive have no intersection set. Mutually exclusive events have no intersection set. That is for the mutually exclusive events. They have no intersection set. All right. So let's look at this example. Try this exercise where we are given an example here. This exercise. Are we together? Is everyone with me? Probability of A, if it is 0.5, 0.6, probability of B, 0.5. Then probability of A intersection B, 0.2. Okay, so find probability of A given B. And the first, second, the other one, probability of B given A. And probability of A union B. Then probability of A complement intersection B. Then probability of B complement intersection A. All right, so we have this kind of equation. That is number 5. Then A and B. Yeah. Together.
Mezilangi. Penze na hivi kwa mimi hizo sasa nshaka bocho kwa panja zantia.
So events A and B independent. Okay. So the question is here. Who can answer the quiz question for us? Probability of A 0.6. Answer this one. Try it now. So this is a conditional. A given B, B given A. These two are conditional probability. Are we together?
Yes, we are.
So answer for me. Probability of A 0.6, B 0.5, probability of A intersection B 0.2. Okay, so this is 0.2. So find A given B, B given A union B, A complement intersection B. This is A bar, A complement intersection B. Then the other one is B complement intersection A, and A and B independent. And then the other one are A and B mutually exclusive. A and B mutually exclusive. So I've given you 5 minutes to try this given problem to find out what answers everyone else is going to come up with. Please try this one right about now. What answer are we getting?
For the first one, I'm getting 0.4. Then the second one, 0.33.
What answer are we getting? What answers are we getting?
The first one is 0.4.
Huh?
Probability of A given B.
So the first one, you said the answer is what? What's the first answer?
0.4.
0.4.
Okay, that's very correct. Very correct. Then the other one, probability of B given A.
0.333.
Okay, so okay. 0.2 divided by 0. So it's 0.333. What's the probability of A union B?
0.9.
0.9.
Yeah, everyone else is with a sign. So probability of A 0.6 plus B 0.5 minus, so it's giving us 0.9 also. How together?
Correct, yes.
Yeah. So probability of A complement intersection B. What else are we getting? So we've got probability of B minus probability of A intersection B. So probability of B is 0.5 minus 0.2. So the answer is what?
0.3.
You are very correct. I'm impressed that people are following this kind of cosine. Very simple course. What about the other one? B complement intersection A. So it's got probability of A minus probability of A intersection B. So probability of A is what? 0.6 minus intersection of 0.2. The answer is 0.4. How together?
Yes, yeah.
Okay. So A and B independent. So carry out one test for independent events. So one test, you only carry out. So these events will not be mutually exclusive because already they have the intersection set. So they are not mutually exclusive. They are, because mutually exclusive, they are disjoint events. These are mutually exclusive. So these events are not mutually exclusive because they have already an intersection set of 0.2. So now the other thing is, are they independent? Cut out a test for independent. So you simply say probability of A intersection B is equal to probability of A multiplied by probability of B if you are independent. So you see 0.2, so you come across 0.2. So here 0.2. Is it equal to probability of A and B product? A is 0.6 and B is 0.5. 0.6 and 0.5. So 0.6 here multiplied by 0.5. So of course 0.2 is not equal to 0.3. So these events are not independent. They are not independent. That's what it means here. How to get? Oh, this is test number 1. Number 2 test. Probability of A given B is equal to probability of A. If you are independent, if this one don't want to go for it, go for the second one. Probability of A given B is equal to probability of A. So A given B is what? A given B we found, which is A given B will give me the answer for A given B already, which is 0.4. I'm happy that you are following. So 0.4 is it equal to probability of A. So if one of them fails, meaning like just use one of these techniques to test, probability of A is 0.6. So not equal. So these events are not independent. The other way, similarly, probability of B given A should be equal to probability of B. So this is if events are independent. So B given A, we found what? 0.333. 0.333 is not equal to probability of B. Probability of B is what? 0.5. So these events they're not independent. Unless if they're recorded. So meaning, if you're not independent, what does it mean? Because these events are not independent and they are not mutually exclusive. Because if they are mutually exclusive, they shouldn't have a set of intersection. So meaning, these events could be dependent events. They could be dependent events. Dependent events. They could be dependent events. Altogether, have people followed so far?
Yes.
I'm asking that have people followed so far?
Yes, we followed.
So this is only the aspect of the conditional probabilities for testing for independent events, and of course also testing for conditional probabilities to find if they are independent or if they are, as I mentioned, mutually exclusive. They are disjoint events. They have nothing in common. They have no intersection trait. Okay, so this is about what is going on here. Looking at finding the probability that are conditional mutually exclusive events, disjoint. This is a very, very important part of the probability that you need to understand. Okay, so now let me give you the last example. Okay, if you are given the okay, so if you are given the another exercise here, another example. Okay, so if you are given another example here, let's say you are given a probability of A. I want people to participate now here. Probability of A, if it is 0.3. Probability of B, if it is 0.7. And then probability of A given B, if it is 0.4. Who can give me the probability of A intersection B? A intersection B. That's number one. All together there. Are people with me?
Yes, yes.
Yes.
So we can answer for the first question. And then the other one.
Yes, sir.
So I want you to get me the probability of A is 0.3. Probability of B is 0.7. Probability of A/B given is 0.4. The first one is the answer I need. And then the other one, probability of A union B. Then the other one, find the probability of B complement intersection A. And then we're going to solve these questions together as quickly as the last example that we're doing. Probability of A complement given B. Then probability of B complement given A. Okay. And then testing if these events are, of course, when you are, anytime you find the intersection set, it means that the events are not mutually exclusive. If there is intersection set, meaning events are not mutually exclusive. Okay. So who can give me the answer for the first one? Probability of A intersection B. What's the answer for the first one?
0.28.
0.28.
0.28, correct. Yeah, we are following then. So what it means is that you did the formula first of all, not so. Which means probability, you did probability of A given B is equal to first and foremost what probability of A intersection what? B over probability of what? Probability of B. Not so. Are we together? Are we together there?
Yes,
Yes.
yes.
No. Maybe kindly explain again. I'm a little bit behind.
You know what?
I'm a little bit behind. Maybe you can kindly explain again on that one.
Okay. The probability of whom? A given B. A given B is equal to probability of A intersection B to a probability of A. That's the formula for probability of A given B. Because the probability of A intersection B over probability of B. So A given B, we have been given here. What's our A given B? 0.4 also. Are we together? Are you with me?
Yes, we are.
Lower probability of B, okay. Lower probability of 0.7. So 0.7. So as we cross multiply, you can find probability of A intersection B is equal to 0.4 multiplied by 0.7. So the answer is 0.28. That is the intersection now. And we need to go. Okay. Then probability of A union B
0.72.
probability of A union B. I gave you the formula to say, okay, no, this one can use the Venn diagram or like a formula which I gave you. Okay. You have to subtract the conflict of interest, which is the intersection. So A, bit of A, which is 0.3. So A is 0.3. Probability of B is what? 0.7. Then the intersection set is what you are from finding. 0.28. So you can get 0.3 plus 0.7 minus 0.28. So you did what answer did you say? 0. What?
0.72.
Correct. So if you had to find probability of B complement section M, probability of B complement section M is equal to probability of A minus probability of B intersection M. So probability of M, we have 0.3. So it's 0.3 minus the intersection set of 0.28. So you can find them. The answer for that one.
0.02.
0.02, correct. What about the other one? B probability of A complement intersection B, what will be the answer? So got probability of B minus probability of A intersection B. Probability of M intersection B. So probability of B, check for it, is 0.7. 0.7 minus 0.28. All right, so this is about
0.42.
Correct. 0.42. Now, who can give me the answer for probability of A complement given B? A complement, probability of A complement given B. Okay, what's the formula here? The value of A complement section B or probability of B. Okay. Now this one, A complement section B, we are from finding 0.42 on top. What probability of B, which is what? Probability of B is 0.7. Are you getting what I'm saying?
Sorry, the one that we found 0.42 was for which one?
Okay, the one for 0.42 was probability of A complement intersection B.
Okay.
Are we together?
Yes, we are.
What about the others? What about the others?
Ah,
Are we together?
I'm having hard time to catch up. I joined in a little bit late, so but I'll catch up anyway.
Okay. So this is A complement given B. So we say probability of A complement intersection B over probability of B. A complement intersection B over so A complement intersection B is equal to probability of B minus the probability of A intersection B. So that's how you find it. Probability of B complement intersection M is equal to probability of what? Probability of M minus probability of B intersection M. So this is about what goes on as we are looking at this one. Okay, so if you are to carry out a test for independent events here, you just need to use one of the tests. If there are independent events, of course, when you have the intersection set, we found intersection set of intersection set of what? 0.28. So meaning that these events are not mutually exclusive. So Coming back here, test for independent events, we just have to use one test. Probability of A, section B, is equal to probability of A multiplied by probability of B. Just about this, so our intersection is 0.28. Is it equal to the product of 0.3 multiplied by probability of B of 0.7? Is it equalizing? So 0.3 multiplied by 0.7. So the 0.28 is not equal to 0.21. So these events are not independent. All right. I'm sure people have followed so far, not so.
Yes, we have.
Yes, we have.
Okay, so now this is about what we need to do, what we've done so far on conditional and independent and mutually exclusive. These they go through, they are through together, they are the same, they go as one. Conditional, independent events and the mutually exclusive events. So if you have understood this well and good, please. Is that okay?